Gazdzinska. Hello also to all the people who are joining online. I know that some of them are from Poland. I'm a software architect at Grupa Pracuj. It's a business that is in HR tech industry, and we have more than 1,000 employees across Poland, Ukraine, and Germany. I'm grateful that I can be here with you today and share with you a story. I hope that you'll find it engaging. I must say that if we interpret IDP here as an internal developer portal, those 6 years are correct. But if we were to think about it as an internal developer platform, it's a bit of an understatement. Bear with me and you'll find for yourselves. All right. Do you know that saying that those who do not learn from history are doomed to repeat it? I want to show you not only what and how we built, but also the milestones that company hit and the circumstances, the reasoning that led us to build an internal developer platform. Let's start some 18 years ago, around 2007. Do you remember what did IT in small to medium companies look like back then? Well, in general, it was a mythical monolith monoteam marvel. People knew each other well. 4 of them could maintain the whole system. They knew code by heart. Software was a single glorious chunk of code. Scaling meant that you have to buy better hardware. The business carefully thought about each and every new feature because mistakes were very expensive and the deployment took a lot of time and effort. Users were accustomed to the application occasionally not working because of some kind of maintenance. There were a lot of offline fallback processes in place. In the picture, you can see a 3D printed model of a panda that serves as an instance holder. Let's imagine that this is a representation of the monolithic application that our team developed according to the specifications created in the late 2000s. So it works most of the time. It makes decent money. However, after the economic crisis, the market changed rapidly. And the business is now thinking about new features that could attract customers in the non-optimal economy. They have to win potential new customers. They face fierce competition in the market. So it's decided that Panda's arms should move, its eyes should be open, and it should hold a candle instead of an incense. Developers say that, okay, no problem, it will take more or less 2 years to properly design it, document it, then build it and test it. At this point, CFO has a heart attack. So developers quickly add that, no, but well, actually, we could make some shortcuts, we could make some nasty hacks in the monolith, and after applying those nasty hacks in solution, we can deliver a patched up version sooner. Guess what the business has chosen? All right, fast forward 5 years of tireless patching and hacking that required more and more people who were more and more stressed. When I joined the company in 2015, the decision has already been made. It is too expensive to build a new model, to print, let's say, a new model every time the requirements change. And it's getting impossible to collaborate in one code base full of shortcuts and full of hacks, especially now when there are almost 50 people in the department. So we should continue with the microservices architecture rather than with monoliths. And let's think now of building systems from microservices as something similar to building 3D models from Lego bricks. I'm sure that we are familiar all with Lego. We see that it's different from printing each time a new model, according to the documentation. The process is full of trial and error, of changing your mind. And maybe the panda is not yet perfect, but it is functional. And most importantly, it can morph into orca or a penguin if the business decides it's now what the customer wants. What is more, we can split up the work required to build a model between a couple of teams, and they do not come in each other's way. One team can build head, the other can build belly, and when there is time to integrate, they do it, and the model is finished. But there is one catch. Both teams have to figure out some problems on their own, similarly. And to reduce that kind of duplication, um, the company decided that we can make things easier for the developers. And the side effect will be that the progress in using novel technologies should be made quicker. So the first platform was created. Named after the Roman goddess, Juno, it is a platform providing cross-functional capabilities such as service discovery, connection to RabbitMQ, connections to database, you can name it. And it provides those capabilities in the form of shared libraries and services. So Juno is not the framework. It does its best to limit the required dependency in that way that programmers can still choose their favorite dependency injection libraries or logging libraries. And it's good to add that Juno is still actively, after those 10 years, developed to these days and used. Okay, now that microservices, aka models built from Lego, emerge, the teams are encouraged to use Juno to support the distributed communication between the services. We are about to find out the sheer joy of stepping on a Lego brick, meaning that it's only a natural consequence of switching to microservices and having a distributed architecture that more unavailabilities and incidents occur. So, a cyclic meeting during which teams are encouraged to discuss short postmortems and learn from each other's experience is born. Such things are discussed as detection time, detection method, cause of the incident, steps taken to restore, restoration time, how to reduce detection time of such an incident in the future, and how not to repeat it. All right, time passes. The teams are getting better and better at microservices. Fewer outages occur thanks to the postmortems, and programmers gain experience in the stack. So they're trying to make their lives easier and more enjoyable. Each of about 7 teams develops its own templates, its own standardizations, and ways of configuring things. And meanwhile, 2 architects are trying to help the teams and still develop Juno. Lessons learned from incident reviews lead us to the conclusion that a set of baseline non-functional requirements is essential for the software to be successful. Most prominently among them is the minimal unit test coverage level, even if set quite low, at the beginning and only for the new code? Well, when there are rules in place and that there is a group effort, some kind of supervision is needed. And supervisors need metrics and efficient monitoring to see the overall picture. We decided it's time for a new tool called fisheye to let the teams know quickly that quality of their software is below an established threshold. Uh, to be more precise, the manager responsible for creating weekly Excel reports on software quality got bored with it, and he decided that it can be done better. And because he used to be a programmer, he decided to scratch such a web application. You can see two pictures, two reports from that application. The first one shows the projects that are missing unit test coverage reports, and the second one represents team reports. Each rectangle represents a team. If a rectangle is green, the quality of team's project is all right. If it's in red, then the team has to work on something. So now that the teams are accountable for the quality of their apps and they learn much quicker that something is wrong, also managers and product owners, even those who don't have technical background, are able to tell that the software needs to be worked on. How was the tool built? Well, users access the web application called Fisheye Viewer, written in JavaScript, that requests API. It is a REST API written in .NET that reads the data from Azure NoSQL Cosmos DB, that gets the data from the batch cron jobs. And the set of cron jobs is called Fisheye Updater, and Updater asks external APIs in order to gather the data. The APIs such as GitHub, TeamCity, Jira, and SonarQube. Maybe even some more. At that time, gathering those information wasn't easy because almost every team fulfilled the same requirements, in their own way, and they configured things differently. This is the actual quote from the beginnings of the fisheye. So extracting the information is complicated. You are creative in configuring the services. And you could argue that it's a good thing. It doesn't matter how each team is working, as long as they are producing well-crafted software. And it is true, I'd agree, but as long as they are living in completely separated environments. But things can get difficult. For example, if there is time to integrate or to change ownership of any application between the teams, or when programmers change teams and have to now learn completely new tricks. Don't get me wrong. I'm not implying that it's not doable. As you can see in the picture, it's possible, but just see for yourself if it's worth it and sustainable in the long run. Anyway, let's continue because some cool things are about to happen, a revolution, if you will. The teams reluctantly adhere to the standards and they more or less are able to integrate. It's getting quite apparent at that time, unfortunately, that their velocity suffers. You can hear during the refinements such dialogues as, wouldn't it be better if this was created as a new service? Maybe it would, but the setup of TeamCity, Octopus, fulfilling of non-functional requirements, or this is a fairly simple functionality to implement. How long could it take? 3 weeks minimum. How come? Well, just the setup takes 2 weeks. GitHub repository, email requests for database, the users, the NFRs. And at the time, we decided it's time to address the issue with the initiative. The goal? To minimize the time from 0 to hello world in the environment to be under 4 hours instead of those 2 weeks. Assumptions? Nothing fancy. Interface command line. No manual actions on the dev side needed. No email ping pong. Notifications instead of requests, and no blocking waiting time. The scope? To automate those things that can be automated. So repeatable elements required to launch a very simple functionality, such as scaffolding of the application, GitHub repository, CI/CD pipelines, databases, including application users, RabbitMQ users, so on and so forth. And this is how a star is born. Okay, so in this picture you can see command line tool. PD comes from product development. It was the name of the department at that time. And after typing those 2 letters in the console, the programmer sees all of the commands, all of the features that the tool is able to do, with a pretty description. For instance, if they wanted to scaffold an application, a new .NET solution, they type in pd app, and the command comes in 2 flavors, the cloud one and on-premises, because we host applications both on-premises and in the cloud. Here you can see the JSON that we called a manifest. So a manifest is something that the programmer has to type in in order to let the command know the parameters of the thing that he wants or she wants to obtain, such as the name of the solution, whether the API should connect to RabbitMQ, so whether it should publish events in the future, some things about services that are consuming messages from the RabbitMQ, and also whether the API and consumer should access the database or not. I know that it wouldn't be a good developer experience having to type this manually, so that is why you can see a command pd app cloud example that generates an example of such a manifest, so that the programmer can only change the things they want to change. All right, so if we are to decide to create an app in the cloud, we are to scaffold the application. The tool now takes the templates of the application from the Nugget package repository. And you can see that it is very verbose. It's telling you all it has done, generating all kind of projects, adding references, so on and so forth. When we already have such a scaffolded application, we can then proceed on to create a pipeline in order to build a solution. In our case, it was on the Team City. That command also has 2 flavors, cloud and on-premises, and you already know the drill. All right, so this is how the manifest for Team City command looks like. It's pretty similar, and not by accident. One more feature of the tool is that if you wanted to save the exemplary manifest, you just typed in the option save and you already had it on the disk. All right. Here you can see the other side of the tool. So after the user typed in the command to create a database, the tool created not only databases, but also needed application users for such a database in order for application to connect to the database. All right, and now I need 3 minutes of your best focus, but I promise after that it will be easy peasy, lemon squeezy, so let's do this. How the tool is built like? Well, developer has to be authenticated, and for that we use a mechanism to get identity from Azure Active Directory. I guess now it's called Entra ID. A tool then creates a release in Azure DevOps. The tool passes manifest, the command, and parameters to the release. The releases are command specific. You'll see an example in a minute. And what happens next is two possibilities. The one is that a script is executed on the agent, and the scripts can then proceed on to create a DNS or to create an on-premises database, in our case, MS SQL Server. But, and it's more common path, it can call the maker part of the solution. The maker then asks external APIs of systems such as GitHub, Octopus, TeamCity, Azure DevOps, or it can ask some proxy APIs developed by other teams in the company that are in turn calling external solutions such as Identity Server, RabbitMQ, or Azure SQL. Never mind what was the option we took, the script or the maker, there is some result we have to pass back to the other release in order for it to be able to save the things such as credentials in one of the places for cloud applications in Azure Key Vault, for on-premises application in Octopus project. Okay, so the 3 minutes have passed. Here you can see how one of the pipeline in ADO is looking like. It is for creating RabbitMQ users. So it runs in each of the environments, dev, beta, prod, and there is one job that consists of 7 tasks. And among them, the most important one is to run the maker with parameters. All right, so such an architecture may seem complicated in the beginning, but it has a couple of advantages. It is really easy to extend. So we developed the tool gradually. It was from the first command to the TeamCity one to the Octopus one and so on and so forth, gradually automating the paths, the parts of the path the developer has to go in order to have the solution released to the production. The paths are independent, so if you are to touch one of it, the others are still working and you don't have to constantly testing every one of the paths. They are easy to change, and it is especially important because of the complexity of underlying infrastructure. So if we were to decide that we no longer want to use TeamCity, for example, for building the applications, it's just that one part of the PD tool that we have to change in order to swap it for something not talking to the TeamCity, but something else. It's easy to use 90% of the time. And the 90% of the time is you're creating a new application or you're extending an application that was created with PD tool. So it's according to the standards. It eliminates non-standard approaches. So the tool is so easy to use that no one dreams of doing things their own way anymore. It does speed up the setup. We achieved 2 hours instead of those 2 weeks stated before. And last but not least, we make the security happy. Developers no longer have to get to know the secrets to the credentials of the application. They are just saved automatically in the pipeline. But there are also some not so optimal characteristics of the tool. It is very dependent on .NET because of because of our choices. It is complicated if the case is non-standard, so sometimes developers still have to ask the multiple teams and have that email ping pong, but it's only even less than 10% of the time. The tool works better on Windows, and it's a natural consequence of its dependency on .NET. And even though we Dockerized it and tried to make it work on macOS, we still were running into the issues such as bugs with authentication, and so it really works better on Windows, unfortunately. The tool breaks easily when the proxy APIs or the underlying infrastructure change, and because other teams are responsible for those parts of the platform, unfortunately, sometimes they forget to notice us and change things without noticing us. And people don't read docs. Surprise, surprise. So if you are an author of such a solution, be prepared that you have to answer constantly the same questions, especially by the newcomers, on how to use the tool, even though it's perfectly documented in the GitHub. Also, not much can be taken and used from the market, only client libraries for some APIs, such as Octopus or GitHub. All right, benefits of such an IDP. At least one vacancy net saved. And this is a very cautious estimation, an underestimation in my point of view. But we can imagine that we have at least one more software engineer who can make exciting features instead of having to constantly do the boring setup. Now, measuring DORA metrics, it's much easier because of the standardization. We can have automated API documentation. And it's not to say that we didn't have, for example, Swagger for open APIs or open API documentation before, but each team could have Swagger on another endpoint. So you have to guess the address to be able to access to the documentation. And now it's standardized. So we are also able to have generic dashboards in Grafana, and that makes the time needed for the setup of the monitoring and observability for the whole environment much easier for the teams. We were able to provide the teams with a tool that automates upgrade to the new .NET versions. When the ownership changes of the application, it's much easier for the new owner to be able to understand and release the software. Also, when programmers switch teams, they are able to instantly start on working on the application. They know, at least, if not the domain, they know the specifics, the technical specifics. And creating universal quality reports got much, much easier. But there are some drawbacks. Effortless service setups led to creating sometimes nano services instead of microservices. And we have observed that there is a decreasing understanding of application environment, especially for the programmers that joined the company after PD tool was introduced. So many years in a corporation and yet no restructurization. Here it comes. More than 100 people in the department were split into two departments in a sort of inverse Conway maneuver. Product development morphs into technology, and the technology department has a mission to serve the inside client. For instance, develop internal tools, in-house systems, infrastructure, and platform. And also support non-technical teams in their projects. There is now more time for the development of often neglected inside tools. That's on the good side of it. but it's now also very easy to forget the insight tools and the platform should be treated as products as well. And most importantly, they should serve the needs of people from the other department. 2020, and what a year it was. The one we had too much time on our hands, and we learned that if a code is documented only in the head of our coworker, we can instantly lose the instant access to such a documentation when we start working remotely, right? Bearing that in mind, we wander through the realms of the internet, and this is a great post. I highly recommend reading it, especially just after IT conference. But do you know that uncertainty when you come across something new on the internet and you can't decide yet if it's just a novelty and it won't be able to stand the test of the time, or is it worth learning? Well, this is exactly what we felt when we stumbled across Backstage, something promising from Spotify in 2020. At that time, Backstage was just given to CNCF, and it was still in the beta phase. It was strangely aligned in a good way, though, to our train of thoughts. So we created a proof of concept, tried to make our own plugin and succeeded. And in general, we learned that Backstage works, is flexible, and suits our stack. We were cautious, but we stayed curious, and we saw the potential to finally deprecate parts of our tool and use something out of box that can still be highly customized thanks to the plugin architecture. Moreover, Backstage advertised many functions that we longed to implement but didn't have time to think it through. And somewhere around 2021, the manager who developed Fisheye left the company, and as a team, we had to maintain the chunk of JS and jQuery code dashed off between managerial meetings and emails, and that sealed the deal. So we decided we must deprecate Fisheye Viewer and try with Backstage, especially as it started to have quite a community. Even if at the time it still was in beta phase. It wasn't until 2022 actually that version 1.0 saw the light. So we moved the main feature from the Fisheye Viewer, the Teams report. We could now also simplify the Fisheye API code because of the standardization that BD tool was able to introduce. And we also deprecated the first function in the command line tool, and it was creating a GitHub repository. We chose that function because very often it was used by people who didn't need .NET on their machines. We decided to use templates in Backstage backed by GitHub Actions to recreate such a feature in the Backstage. Here you can see the template for creating new GitHub repository, but not being forced to maintain and develop that old JavaScript viewer, we were now able to easily add new features in Backstage. And here you can see how historically the team's product quality performed. Also, security assessment of products that used to be a quarterly updated Excel found its way to Backstage. Similarly to lists of non-functional requirements that are now editable in Backstage, while they used to be stored in Markdown files along with application in the repository. Another helpful indicator for the teams, a slide trends for any application. And that brings us to current times. In 2024, we started to experiment with GitOps. In short, a programmer writes a description of what the application needs to run in our own domain-specific language. And then GitHub Action interprets it and creates Terraform files with infrastructural changes needed to be applied. And what's next? Well, probably we have to deprecate the command line tool, or its function will be to create the new DSL app description for those who prefer command line interface, along with a template in Backstage for those who prefer GUI. We will surely continue to add new plugins in the Backstage. And most importantly, we will stay curious and always on the lookout for new shiny objects. And thank you. I'd be grateful for any feedback that you can provide using the QR code. And if you want to contact me in the future, feel free.
Cool. Thank you so much. Another round of applause. One water.
Thank you.
Amazing. Great story. There are some questions. So basically, you started talking about the original system and how it evolved, and at the end, you are going to use Backstage. Did it change also the amount of engineers that were using the tool at the beginning? And
Yeah, absolutely. So in our company growth constantly from around 50 engineers to then around 150, let's say, and then back to about 100, more or less. And depending on the number of programmers, also the technologies they use change. So yeah, we have to evolve.
Cool. We initially had a question about if PD tool was able to also to generate infrastructure as code, and then someone said, you can delete the question that I asked because now you're using Backstage, but also, are you also generating infrastructure as code via Backstage or even in the previous tool?
Actually, it is more done at that time, at nowadays time by the DevOps team. So PD tool does only a small part of it, the TeamCity Kotlin files.
Cool. Any other question from the crowd? Yes. Wait 1 second, otherwise they can't hear you online. No worries.
Have you looked into Aspire now? So the new platform?
Yeah, it's something that we want to look into in more details. We haven't been yet able to experiment with it, but it sounded really promising. Yeah.
Amazing. Any other questions? Sure.
You mentioned at some point you reorganized, you reviewed the organization, and you did this inverse Conway maneuver. What was the trigger, if you can share?
All right. So the business realized that some of the insight tools used, for example, by customer care or sales department are somehow neglected, while the teams are focused on developing products that are accessible by the customers. And so they decided if we create a separate department to be able to focus on that insight tools, then the insight tools will thrive. And I must say that it's sort of, yeah, I think that after all this time, after all turbulences, and the ways we had to restructure our communications and still try to communicate with each other, especially for us as an architecture team, it was a challenge. So that the product teams don't forget to include us in their development process. But after all, it did what it should have done. So the insight tools are now not neglected as they used to be. And we had time to develop the platform.
Cool. Thank you again. Thank you so much.